first on your own. So draw the picture first on your own, and then we will see how you did. So here's my building. Here's my flagpole. And you are 125 meters from the foot of the building. It doesn't matter if you go to the left or right. Some people had going to the right, some people had going to the left. This makes a right angle right here. Now we have angles of elevation, so that's from horizontal looking up. That's the same word as angle of inclination. To the top and bottom of a flagpole are 40 degrees and 30 degrees. Do you know what this word means in English, respectively? That means that the 40 degrees goes with the top and the 37 degrees goes with the bottom. So if I was looking to the top of the flagpole, this angle is 40 degrees. That is the angle of elevation to the top. If I was looking to the bottom of the flagpole, this angle is 37 degrees. We want to find the height of the building and the height of the flagpole. So I'm going to call the building X, the flagpole Y. Now this is pretty cool because it means that if you had this situation, you could use your clinometer, measure a certain distance away, and with that clinometer be able to figure out how tall something is on top of a building. Now this is the first thing that's going to be hard for you. How many triangles do you see? 2? 3. Okay? Take some time until you see 3 triangles. Does everybody see 3 triangles? Not yet? What I'll do is I'll draw them out. Everybody sees this triangle, right? Right? Whoops. Take that red one. Come on. Why doesn't it want to move? There it is. There's the red one. We'll do that one first. What could we label on the red one? We know this is 125. What else do we know about the red triangle? This is 37 degrees. And that's 90. Second one I'll do in green. Everybody sees this one second, right? What do you know about this triangle? We know that this is 3 degrees. And the triangle that people don't see right away is the big one. What do we know in the big one? We know that that's 90, this is 125, and this angle is 40 degrees. Only 2 of these triangles are right triangles. For this green one, we can't use SOHCAHTOA for it. We can't use our definitions because our definitions only work if we have a 90-degree triangle. Now let's look at what we're trying to solve on our original one. Can you see that only this small triangle, the red one, has enough information to solve? And one of the things that we wanted to find was x, which is the height of the building, which was right here on our red triangle. We can also solve stuff on our blue triangle, right? Yeah, not only our red triangle has enough pieces of information, our blue triangle has enough pieces of information. Did we pick a letter for this side on our original diagram? No. We said that that whole thing would be x plus y, right? Does that make sense? This whole side, do we want to choose a new letter? Do we want to call it z? And you know that z is equal to x plus y, because on our original diagram, this whole thing from here to here is what we're going to decide to call z. So now we've drawn out our picture. Now come up with a plan. What can we solve for? We can solve for x using the red triangle, and then we'd have the height of the building. We can solve for z using the blue triangle. Then we would have the height of the building plus the height of the flag. How would you find the height of the flag? Yeah, whatever we get for z, we just subtract x and we'd be left with y. So we draw our diagrams, we come up with a plan after our diagrams to say, can I solve this? And then once you have your plan, you can go about doing it. So we'll start with our red triangle. It is a right angle triangle. We can use SOHCAHTOA. We look at this, we want to find x. According to the angle that we have, x is the opposite. So we know that we have to use either sine or tan, because those are the only ones with the opposite. With the angle that we have, the side that we have is the adjacent. So now we know we have to use tan. So tan of 37 degrees, opposite over adjacent. Multiply both sides by 125. Take out our calculator. $125, tan 37, 94.1. I'm going to store this as x because I think I might need to use that later. Now I'll go to my blue triangle and I can find z. Again, I have the 40 degree. This z is opposite that 40 degrees. So we know that we have to use sine or tangent, because those are the only ones with opposite. Again, the 125 is our adjacent. So with the blue triangle as well, we're going to have to use tan. Tan of 40 degrees equals opposite over adjacent. Multiply both sides by 125. $125 tan 40, 104.8. So we found x, we found z. If we go back to our original diagram at the beginning, we know that, we know what z is. And I forgot the numbers. 104.8. We know what x is. 94.1. And once we label it back on our diagram, we can see I can find y by doing 104.8 minus 94.1. So let's go down to here. I can find y by going 104.8 minus 94.1. Again, we don't want to round early. On my calculator, I already have 104.8 built in. So I can just hit the minus sign and it'll say, take that answer of 104.8 and subtract it. And what do I want to subtract? I want to subtract x. And I already stored that value in there, so I can just go subtract x, push enter, and I get 10.7. Did the question ask us for a certain type of rounding? It's one thing I always check at the end. Find the height of the building and the height of the flagpole? No. So we can leave it to whatever decimal places we would like. Okay. It's a word problem, so we end with a sentence. The height of the building is 94.1 meters. It's a pretty tall building. The height of the flagpole is 10.7 meters. I like to circle my final answers. So now let's recap what we did. We drew our diagram, and I think this is one of the hardest two triangle ones to do because one of the triangles you have to solve for is hidden inside. It's that big one which was the hardest triangle to see. Some people are able to just draw the one diagram and then solve from there because they can see everything in the one diagram. Some of you might prefer to draw the separate triangles out. I wouldn't even draw the green one because it's not a right angled triangle. You're not going to be able to use it for anything. But I just wanted to show you what it looks like. Then once you have your triangles, solve for them. Again, I color coded it so I knew what I was working with. And after I solved for things, I went back to my original diagram and labeled them. Because when I go back to my original diagram, it helps me see, oh, if I have z and I have x, I can find y by just subtracting. And then once I've solved for everything, I can write a statement to say what my final answers are.